All right, I assume you guys can see my screen. All right, let's get
Yes.
started. Hi, welcome to a new session of the script is specific script TS. And today, we are going to cover, I think, two things. Number one is a new CRI tool we just had, after the new year to streamline a lot of things which we have to manually config before. And the second thing is, we talk about the package management on of script, and we previously hint how we don't have a script specific package management. You can just piggyback on the so-called NPM, which is one of the most popular, if not the most popular package manager out there. So let's jump straight in. So first of all, I want to introduce you to this new CI tool. So before, I think it's kind of the before the new year. You can, if you still remember, when we first started, when you have to install things, you have to go, install a bunch of things and then manually config this JSON, that launch.config. Yeah, there's a lot of duplicative work and laborious work. So that's why we create this CRI tool, which you can run from command line. So you can just, for anybody who's just getting started today, instead of doing all these mundane things, you can just go there and install this CRI tool. After that, you can, you can create it's almost like the tool that's going to, help you with all of the following sections. So, it's also open source. So if you click this tool, this link, you're going to divert, redirect you to this GitHub repo. Basically, it's all the source code for the CRI and all the instructions. So, for example, the number one thing you want to do, if you want to start a new project, you can just create this new project. So that's with just one line, everything is ready to go. You get all the scaffolding and all the configs ready. So you don't have to do anything, complex as before. So you can create a new project, but you can also compile your smart contract with this command line. And today, I think I'm more talking about, using the CLI. How do you publish your contract, and so other people can reuse it, right? Because without the package management, the code reuse is very difficult because people have to you have to publish your source code, and then people pretty much have to manually copy and paste the source code. And if your code changes, it's not straightforward to see how the downstream user is going to upgrade. So with NPM, we are going to show today, it's as easy as any other TypeScript file or script packages. So let's jump. So I just pause a little bit here. Any questions about the CRI if I've not been using it? Okay, seems straightforward. Let's keep moving. So today I'm mostly talking about how to publish a contract. So again, it's on our documentation side. I think I'm going to also post the link in the show notes. So the little difference is that if you remember all the previous smart contract we have written before, it extends a base layer called smart contract. So instead of smart contract, you have to extend this smart contract lib. So basically, meaning it's a library. So what's the difference? Why do we have a different base class? It's mostly because if you think about a smart contract, you usually have some public method, right? So you can, once you deploy it, you can interact with it by calling its public methods, right? But for a library, usually is some common function code. For example, you want to do some, let's say, floating points. You want to do some fixed points. You want to have a library for, elliptic curve, arithmetic. So all this is not generally, you don't directly call it, from off-chain code, right? So that's usually it's not standalone. It's usually some kind of like a, almost like a utility functions, a group of utility functions. So that's why, for example, here, we want to just have some, let's say we want to have a function. I mean, this is the simplest example. You want to add two numbers. Maybe you have much more complicated. Let's say you add 2 points on a elliptic curve, right? So that's why that's the first big difference. You have to, instead of extend a smart contract, you extend smart contract leave. Okay. And then the second thing, I think I kind of hinted at it before. So if you notice here, if it's a library, you cannot be directly deployed and called. So that means there's no public, if you notice all here, there's no public methods. So basically means you can only be imported in some actual contract and then be used there. You cannot directly deploy it and interact with it. Okay. Any questions so far? Why is it different from the previous smart contract class? Okay. Yeah, if not, we can keep going. So again, as I said earlier, when you have a contract library, you cannot directly deploy and call it. The way you do it is you can import it. You can import it into a smart contract subclass, for example, my contract. So you can here, assuming you already get this thing, you can import it from the package, and then you have the mylib here. So once you have the mylib, it's like any other class, right? You can instantiate it, and then you got the instance of this library, and then you can use all its function. For example, we use append here, so we can also use, it's all its member methods. We can use append here, or we can use add. Okay, so one thing to notice is, because this add is a static function, so it's bound on the class. It's not bound on the object. So because this is not a static function, so you see here you have to new instance and then call it, versus the add, because it's a static, so you can call it directly. Okay. So once we have a way to create a library, and then you can import it. This is pretty much locally, right? And then the next question we could ask is, hey, how do I publish the thing? So here's the difference, because we talk about at the very beginning, ASCII TS is close to raw TypeScript, but it's still a little bit different. So because it's a domain-specific language, so it's the publishing when you want to publish the whole library to the NPM is a little bit different of a workflow. So instead of using the usual, you need to combine it and using some kind of like a Webpack type of thing, and then upload it to NPM. So we kind of streamline everything here, by again using the CLI we talked about before, right? So if you notice, you can create a new library project, again, we're using this command project, but you can notice that here, that's an option. It's a different option that's been turned on. So the CLI knows, hey, we're not talking about a smart contract here. We're talking about smart contract library. So it has to be, this switch has to be turned on. And then you can put it out just library name. And then once you have this and you do the normal process, you can write the library, you can even test it. Test it is also very similar to what for the smart contract before. The only difference is, if it's a static function, you don't have to create a new contract. You can just test it directly. But if it's not a static function methods, you have to create a new smart contract so you can use this, so you can test it here. Okay. So once we write it, we have tested, and then the next question is, how do we publish it? Again, if you have created the project using this command, it's very simple. You just run this single command, and script publish, and then everything will be handled behind the scene. You don't have to configure anything. So if you publish, and then you will show up in NPM. So once you have your own library showed up in NPM, then it's like any other NPM packages. You can do it, you can import it via this syntax. You can just import it and leave from your library. Okay. I go to pause a little bit here. Any other question about the workflow so far? Or if you are already using NPM for your JavaScript or TypeScript, this is almost exactly the same.
Yeah.
Okay. So, okay, that's good. So we just dived into, the basic CLI and also how to publish a library, write a library and publish a library. So I think going to today, because we still have some time, and I'm just going to, cover a little bit of advanced usage for when you publish a library. So, okay, how many people of you have heard AScript, not AScript, TypeScript before? How many of you have used raw AScript before, vanilla version? Anyone? Based the previous the new programming language we released.
Yeah, not much, a little bit.
Okay. Yeah, so if you have used the AScript, we have this contract, we have this concept. Let's just go to the docs. So basically, it's a new standalone high-level programming language. Its syntax is also similar to TypeScript, but it's not. It's a different language. And there, we have this, we have this trick. So basically, it's like any other high-level language, right? It's very easy to get on, but for a lot of times, it's not going to be the optimized code you can have, right? So it's very similar to, let's say you have C++, right? You can write some, if you have, let's say, x86 instruction set, you can write, you don't have to touch the lower level assembly code, but you can, if you have a C code and C++, if you have very performance demanding applications, a lot of times you can hand optimize them, right? By using, the assembly code directly. That's a usual trick, right? So same for here. If you're using AScript, what we enable you to do before is, you can actually directly code in Bitcoin script. For people who have not heard about, all the language we talk about, AScript or AScript TS, eventually when you compile it down, it goes to the Bitcoin native instruction set called the Bitcoin script. Okay, so for example, you have drop, you have leave. It's a stack-based language, but the bottom line is, if you really know what you are doing and you want to optimize your script to be very performant, you can do it. Okay, so this is how you do it. For example, I just give one. This is almost one of the most famous example. So basically, when you send regular payments from Alice to Bob, right? We call this pay to public key hash. So you can write it in high-level language like AScript or AScript TS, but it's not going to be optimal because it has some overhead. And then if you really know what you're doing, you can directly code. For anybody who has been into Bitcoin script, this should be almost like a hello world. So I'm not going to explain what exactly this means. Basically, this is the optimal code if you want to implement this contract. So that give us the question, right? That's the question. What if I write my library, for example, elliptic curve or 0-9 proof? What if I want to optimize my code? So what did I do? Because if you notice in AScript TS version, right? There's no way, there's no standard way for you to write, directly in Bitcoin script, right? There's no, inline assembly mode. Okay, we try to avoid that because TypeScript is very high level. We don't want to confuse users. At least so far, we don't allow them to directly modify the TypeScript file to include Bitcoin script. Okay, but we have a lot of old libraries. Our people have written a lot of old script code, and it's highly optimized because they write in Bitcoin script directly. So we will also want to provide them an option without having to rewrite everything. So that's how we go to use this advanced, library feature. So basically, the way script.ts is uses the intermediate language called script I just mentioned, right? So after you have compiled script type compile, you got this pretty much all these files, under your package. The modules, your package, you got two types of files. One is it's like any other TypeScript file. You got the JavaScript file. You got all the definition, d.ts definition files. But in addition, the only thing different from between script.ts and the normal TypeScript is you also have this intermediate file called script file. And if you remember, I just showed you, if you use script, you can actually code in native script, Bitcoin script as well. So the trick is it's kind of manual for now, but it can work, right? So basically, after you compile, you have the intermediate file, and then you whatever optimization you can have, you can just replace all the functions with a Bitcoin script, optimized script, and then you publish it. Okay, does this make sense?
Yeah. Do you have to do that every time you change it though? So if you made a change in the original TypeScript, you'd have to remember what you did before, yeah?
What do you mean by change it? You mean you recompile it, or?
Yeah.
Oh yeah,
every time you recompiled, every time you made a change and recompiled. Yeah.
Yes, because this is when you compile. But here's the thing, right? You don't. I recommend the workflow. I think we need more documentation, but the workflow is you just you make all the changes you wanted before, and then when you finalize it, you have this,
yeah.
and then you replace it, and then you can rewrite. But again, if you decide to change it again, you have to put it this. You have to replace it again. I think we are going to have more like a streamlined workflow, maybe some kind of like a hook, so you don't have to, when you recompile and you tell the CLI somehow, you don't want to override this file. That's also, yeah, it depends on how people use it. Yeah, for now, yes, you're right. You have to finish all the library, finalize it, and then you replace it, and then you type script publish. Okay.
Okay, thanks.
Good question. Yeah. So this is a very neat trick, and we are using. So the example here is, we have a lot of libraries we have written before. So think about this like a standard script library, and we have written a lot of code before. So we are porting on many of them and putting this common library code. So we have a lot of common code. A lot of our contract we'll use. For example, I just talked about elliptic curve, right? So a lot of our contract we are going to cover later. For example, when you want to do different signature scheme, like a Schnorr signature, or you want to do some kind of like a encryption, a lot of cryptography is going to rely on this primitive. So that's why we have this, lib, and we implement all the common functionality. We have hashing, we have encryption, decryption, we have different signature schemes. Also, we are going to have zero knowledge, and also floating points, and also how do you verify signatures using so-called Robin signature. So you can enable oracles. So all this common functionality, we are going to port them over and put it here. So you don't have to worry about, you can just build upon it. You don't have to know all the details about it. And because of the trick I just mentioned, it's all going to be hand optimized because we don't want everybody to start from scratch. We have built a lot of experience before, so we use this technique to build the optimal version. And then when you are ready, you can just import this library, and then you get all the functionalities you want. I just talked about a few, right? Elliptic curve, zero knowledge proof, and rapid signature enabled oracles, and different signature schemes, and all the cryptography, like encryption, decryption, proof of computation, all the commonly used libraries we're going to put in this library. So you can just import it once and then do a lot of things that you can not do before. And so also, just as a reminder, who was, some people are present here, but if you're not, I sent an email pretty much giving out some homework before. And if you are one of the lucky people who has been chosen to run some, for example, elliptic curve, the smart contract based on elliptic curve. We already have the elliptic curve, so you don't have to rewrite the whole thing again. You can just import this library and use the elliptic curve library come with it. And so you don't have to write the primitive. You only need to build upon it. Okay. And also we also welcome all the people who have good library skills. If you want to become part of the almost like a standard library, you're more than welcome to put the submit PRs for us, and we are happy to incorporate it into this library. Okay. Any questions so far? Okay, that's good. So I think it's today probably going to be a short one. I just want to highlight the CRI. How do you use it? So you don't have to run all the manual configs before, and then talk about the library. How do you write the library, and how do you write it, how do you test it, and then how do you publish it. So once you publish it, you can also, if you have no specific optimization tricks, you can also optimize it if you want. And then all the while, we have all provided a wide range of standard libraries you probably need when you have any kind of a substantial smart contract you want to write, and it's all put in this common library. So, and the good thing is here, there's not much. I think the only difference is, instead of using your normal publishing workflow, you just run this command. And when you create this project, you have to give it this option. So everything else is like, is the same as the normal TypeScript and NPM. Okay. Any closing comments here? Okay, as a reminder, please try to finish the homework after assigned before. I think the best way to learn some tools like ScriptTS is going to just use it yourself and see how's it like. How to debug, how to test it, how to deploy it. I think that's the best way to master this library. Okay.
Yep, sure.
Yeah, I think I'm going to send a reminder because that's a few weeks ago, and we have also a lot of updates. So the basic idea is, I think I assign each one a specific contract to work on. It would be great to translate the old script contract to the TypeScript one. That would be a very good exercise. Okay. All right, sounds good. Any other comments? If not, I'm going to see you next week. Okay, thank you. See you next time.
Thanks.
Okay,
See
have a
you
good
next
one.
time.
Thanks, bye.
See you next time. Okay, bye-bye.